Hi, good evening and welcome to this video. And in this video, it's just a little bit of fun that I've just been having where I've actually been gathering a sample of soil. Now, one of the powers of electrochemistry is it's a really good technique for analysing slightly sort of unusual samples. I sometimes, when I'm doing webinars and stuff, I talk about, that electrochemistry is actually a very good science for actually dealing with quite dirty samples. This is actually a soil sample. And I'm going to dig into that a little bit as I go through just a few photos. So I was just kind of generally intrigued by the analysis of soil. So, at ZP, we've worked on measuring nitrate in soil. And, so we've got a little bit of experience with this. But just generally now, there's a lot of people interested in agriculture and making sure that, we sort of treat the soil and soil health in general. So I just weighed out a little bit of soil, 0.1 grams in this particular case, or 0.106. If you're very interested in sort of coming up with biosensors, electrochemical assays for more complex matrices like soil, it's probably worth having a conversation with ZP because we do have some very practical kind of experience with dealing with this kind of thing. But anyway, I'll just tell you what I did. I took the 0.1 grams of the soil and in this particular case, I dissolved it into quite an acidic buffer. It wasn't just what I had at hand at the time, so I sort of dissolved that. And I'm fortunate enough actually to have a vortexer here. So I've got the kind of hardware in front of me at the moment, and I might just do a quick demonstration for you. I am using the Sense It All. I do have a bit of a little lab here, so but I'm just going to pull this forward because this is the vortexer. Now the reason I mentioned the vortexer is because I saw a sample like this. We're often trying to extract something. So in fact, the sensor and the meter itself is really quite small, but you do sometimes have to think about the extraction. Electrochemistry is a good science. But it does like things to be essentially in the liquid phase. With that said, so I've made that statement anyway. So what I'll do now is I'm just going to do a quick cyclic voltammogram analysis actually of that particular soil. I might just call this soil 4. So just forgive me for a second while I just put in that. I'm not paying particular attention to my settings at the moment because I was more interested in actually handling the sample and sort of demonstrating in some ways that electrochemistry can actually deal with, I think it's one of the few kind of analytical sciences where you can take quite a dirty sample like this, no filtration required, it's got soil in it, it's a bit of a suspension, and you can actually put a sample onto the sensor like that. In fact, I can even see a few grains there. So what I'm going to do now is I'm just going to start a measurement. Now I really, obviously, at ZP I'm biased because this is the Sense It All potentiostat, and it's, it's a really nice instrument for actually taking assays that would otherwise just be not isolated, but left in the lab. I'd kind of, one of the big problems that we're trying to solve at ZP is actually coming up with a way of bringing science out of the lab. I think that a lot of scientific research ends up at TRL3, technology readiness level number 3. But really, just with the right instruments, and that's what I'm going to kind of demonstrate here, you can actually bring it out of the lab environment and handle real world samples, like soil, and try and get something sort of meaningful out of it. But anyway, I'll just let these 3 CVs record. The Sense It All platform is very powerful because it's driven by my phone. We can go between all the different techniques of cyclic voltammetry, EIS, square wave voltammetry, amperometry, etc. just using QR codes. And now it said that the upload is complete. So I'm just going to share my screen. This is the next part of this. And I'm just going to do a quick refresh on that. And there we are. I can see the data up there then, the soil 4. But I was super intrigued, see, because this is a soil sample. I could have some suspicions, and it doesn't matter that this sample is not purified, it's not filtered, it's just a suspension of the soil. But there's electrochemical activity in this soil, and this is something that I've been sort of thinking about for a while here. I could speculate. In fact, I even think that that is the oxidation reduction of the same molecule. Just have a look at the separation: 115, 193. So it's not 59 millivolts, but I've got a suspicion this is the oxidation reduction of the same molecule. So there are, and it's not super surprising, I'm sure, to many of you that electrochemistry has the capability of detecting redox active molecules in the soil. I've even got a suspicion that redox active molecules in the soil is in part linked to soil health. What I want to do for a second actually is think to myself. Now I'm just going to go into some tools here. I'm going to turn a couple of cameras off and just I'm just going to go into here for a second. Go into tools. I'm going to look at the third CV, and what I'm going to do is I'm going to go and try and find one of the peak heights. So let me go peak height here. I will center about 250. I'll put in a window of 300. I'm just going to close this quickly just to see how, if I hit the right spot. I should have been a little bit careful. There we are. So I've caught the peak height there. So there's a peak height there. Now, if I had if I did this properly now, I could come up with a calibration for this. Find out what this molecule is. Find out what peak height versus concentration is. But I'm just going to make up let me just do a quick, I can come into here, see, and if I had done that calibration, and I'll just put in 0 here, show extracted values, do that. The really powerful thing, this is really powerful, is now because I just made up some calibrations really quickly, but this is the real power thing about the SensiAll platform. I've actually turned peak height into millimole concentration. So now I've got this. I can actually create a template from this. So every time this CV comes up, it'll automatically find the peak height now. Whatever calibration factor I determined, it will actually then convert the peak height immediately, in this case, into millimole concentration. So it's a very, let's say, powerful piece of technology. So I just want to finish it with, I'll put a link to ZP, but if you're interested in the analysis of soil and the analytes in soil, then I would, and you're maybe in one instance just trying to make a decision whether electrochemistry is the right technique for you, then I would actually sincerely say that it is actually the right technique for you. And secondly, I would say that the SensiAll, and of course I'm biased, SensiAll platform is a very powerful platform where you can go, you saw how quickly I did it. I used a real soil sample. I sent the data immediately to the cloud. I was then able to turn the data pipe on, find that peak, give it some, and I made up the calibration, but actually turn it into a concentration in that particular case. So if you have any questions, don't hesitate to reach out to us. Okay, thanks very much.